Welcome to Mathmo. Today I'm going to show you how to solve some basic right-angled trigonometry problems using the mnemonic SOHCAHTOA. If you're not sure how to work out which trig function to use or when you should be multiplying or dividing, then this is the video for you. I'll show you how to set up some helper diagrams that will make it nice and easy. Now this is going to be quite different to my previous trigonometry video in which I explained the trig functions in an intuitive way and how to identify the sides that are opposite and adjacent to the base angle. If you need help with that, please watch that video first and then come back to this one. So let's look at the first example. We know that the base angle is 40 degrees and we know that the hypotenuse has a length of 3. Now in all right-angled trig problems you need to know two pieces of information about the triangle, so that's great. We can use trig to work out the other side lengths. If you want to know the vertical height of this triangle, which I will label y, then we have to ask which two sides are in play. Well, the side labelled y is called the opposite side because it doesn't touch the base angle. And the other side we know is called the hypotenuse. That's the longest side of the triangle. Now when we look at the mnemonic SOHCAHTOA, which I'll just write out for you now, S-O-H, C-A-H, T-O-A, then we can see that O and H correspond to the sine function. Now if you've seen my previous video, you'll know immediately that y is equal to 3 sine 40, but if not, here's what you can do. You can set up a helper triangle, which is not the same as the triangle in the problem, and normally people would fill in the triangle like this. Starting down low and writing from left to right, we would spell S-O-H. But here's the Mathmo special. We're going to write our letters from right to left. So the S goes down here, the O goes up here, and the H goes down here. If you write your letters this way, you'll naturally write a correct trig expression when you show your working. Now this triangle tells us that the opposite side is equal to the hypotenuse multiplied by sine of the angle, and that's because the H and the S are at the same level. So I'll just write that out here. And in this particular case, we can now write that y is equal to 3 sine 40 degrees. And if you work that out on your calculator, do make sure that your calculator is set to degrees. You get 1.9284, and that's to 4 decimal places. On the other hand, if you want to know the horizontal width of this triangle, which I will label x, then again we ask which two sides are in play, and this time it's the adjacent side, which is adjacent or next to the angle, and the hypotenuse. So if you look at SOHCAHTOA this time, we can see that A and H correspond to the cosine function. Let's bring in another helper triangle. And again, we'll fill it in from right to left. C, A, H. Now because we're looking for the adjacent side, this helper triangle tells us we need to multiply the hypotenuse and cosine of the angle. So I'll just write that down here. And that means we can now work out x, which is equal to 3 cos of 40 degrees. And your calculator will tell you that that's 2.2981 to 4 decimal places. Okay, so far so good. Let's look at the next example, which does catch out a lot of students, but if you follow me, you'll see that it's really no harder than the first example. We still have two pieces of information about the triangle, so we can still use trig to work out the other side lengths. So if we wanted to work out the horizontal width of the triangle, which I'll label as x again, then this time the two sides that are in play are the opposite side and the adjacent side. And SOHCAHTOA shows us that O and A correspond to the tan function. Now again, we'll set up our helper triangle, filling it in from right to left. Now because we're looking for the adjacent side, the helper triangle tells us that we need to divide the opposite side by tan of the angle, because the O is sitting higher than the T. So I'll just write down that relationship here. A is equal to O divided by tan of the angle. And that means in this case, x is equal to 3 divided by tan of 40 degrees, which is 3.5753 to 4 decimal places. On the other hand, if you want to know the hypotenuse, which I'll label R, then the two sides that are in play are the opposite side and the hypotenuse. And once again, SOHCAHTOA tells us that O and H correspond to the sine function. So let's fill in another helper triangle, which we'll fill in from right to left. S, O, and H. Now this time we're looking for the hypotenuse. So again, this helper triangle tells us that we need to divide the opposite side by sine of the angle. So I'll just write that here. H is equal to O divided by sine of the angle. And so that means that we can write R is equal to 3 divided by sine of 40 degrees, which is 4.6672 to 4 dp. Right, this last example is a little bit different because the two pieces of information about the triangle are two side lengths. That means we can use trigonometry to find the angles inside the triangle. So for example, if you wanted to find the angle down here, which I will call alpha, then the two sides that are in play are the opposite side and the hypotenuse. And we know that O and H correspond to the sine function. So again, let's fill in our helper triangle, SOH. And this time, we're looking for the angle. So that tells us that sine of the angle is opposite over the hypotenuse. So I'll just write that out for you. Sine of the angle is equal to O over H. So that means we can write that sine of alpha is equal to 3 over 5. And here's the clever bit. We need to undo the sine function. Now it's very common for students to think that they can divide by sine to get alpha, but that's not how it works. We've taken the angle alpha and we are applying the sine function to it to get 3/5. So in order to get back to alpha, we have to apply something called the inverse sine function. So I'll just do that now. Alpha is equal to the inverse sine of 3/5. And I do recommend that you put the brackets around 3/5 before you put that into your calculator. And you will find that the answer is 36.9 degrees to 1 decimal place. On the other hand, if we were looking for this angle up here, which I will call beta, then the two sides that are in play are the adjacent side and the hypotenuse. So again, let's set up a helper triangle and fill it in from right to left. And the helper triangle tells us that cos of the angle is the adjacent side divided by the hypotenuse. So in this example, cos of beta is equal to 3/5. And again, we think about starting with an angle beta. We apply the cosine function to it to get 3/5. And so to undo the cosine function, we apply the inverse cosine function. And so beta is equal to the inverse cosine of 3/5, which is 53.1 degrees to 1 decimal place. Okay, so that's covered the different sorts of right-angled trig problems that you might encounter. I hope you found this video useful and can see how the helper triangles make it easy to know when to multiply and when to divide. Thanks for watching.